Let's start our lesson. So today we will see the SolidCAM and see the how to write the program for this kind of planar object. So it is the composed by the pocket here, the closed pocket. The here we have the slot, and we have here the circular pocket, and we have the pocket here, the open pocket. So we will learn how to create the program for the closed pocket, slot, the circular pocket, and as well as for the open pocket for this kind of planar elements. So here you need to open here the milling. So this will be the milling operation. Click here the milling, and from here the select the external SolidCAM project, and here you can define the project name. That's the here the let's write here the project tree, and here you define the unit of the measurement, that's the inch of the metric. So let's keep here the metric of the unit of the measurement, and here you can define the folder where you want to save your the project. So I will keep here this one. So just click here to OK. So as usual, in the SolidCAM, the first steps that you need to first define your the coordinate system, the 0 point, the stock value, and the final product. Then you need to define your the post processor, the materials for your the product, and so on. So firstly here, this is our post processor, this is machine. We need to define, and let's use here the Stefanok, this one. And here you need to define the coordinate system. That click here the coordinate system to define the coordinate system. And let's put the coordinate system that is on this face exactly in the middle. In order to do this, let me just check here. This one is the top center of the model, this option. And here the select the face is this face of the model. So, and here the 0 point of the product will be the exactly it will be inserted on this center point. So this is the coordinate system. We can click OK. Now just click OK here. Just leave these values. It's just the clearance values for the tool moment, and this is the just click OK here. That this one also. So we defined the coordinate system. Now let's define the stock value. So click here the stock. So in this case, let's use the stock value. That's using the here the extruded bounded option, and check here that these two options is selected, is active, and this one is the curve. And in this case, just click here the edge of the model, the lower edge, for example this edge, and you see the stock will be decorated, generated. That's automatically taking the same shape of the model, and click here the yes, and this is the stock, the limit value. So exactly the taking the same shape of the product. So click OK here, and so we defined our coordinate system. The stock and target is defined by the system, that's automatically. So, and here the target is this final product. So we defined coordinate system, stock, and target. Now here you can define the material for this product. If you open this menu, and you will see here the available materials. That is, you can select any material that you want to use. That's for example, let's use the cast iron, the alloy, the cast iron for this product. So we define it here the initial settings for this operation for the SolidCAM. Now we can click here OK. So SolidCAM will be open. Let's wait here. So we opened the SolidCAM, and here that's usual that you can see here by the right click to show. So this is our stock value, so stock material, the raw material. And if you want to see here the target, that's the final product, the right click, and here they show. And this is the final product after the machining operation. So we made here to this initial setting, and now we will go with the operation. So first we will see here the slot milling, how to create the slot with these steps. And let me check here the depths. In order to do this, go to the evaluate. Let's make here the measure. So distance from here to here is the 10 millimeters. So here you can see the normal distance is 10. So the distance of the slot is the 10 millimeter, and we need to create here the program for this slot. Here, click here the SolidCAM operation from the tab, and here you need to open this operation for the slot milling, and here we need to use this one. That's a slot for this kind of slot. So click here the slot operation, and this menu will be opened for the slot operation. And first we need to define here as usual the geometry as the boundaries where you want to just remove the materials, the boundary points. So in the geometry, to create the new geometry, you need to click here the new. So in order to define the geometry, and let me check here that this should be the active here, this and the curve option. Let's use this one, and here select any edge of the slot where you want to make the machining, that lower edge. So click for example this edge, and here it will automatically just select all the edge, since here the tangent and constant is this was active, so it will automatically select all the edge of the slot. So close it system, then click here the yes to accept this boundary. So we defined the boundary, that is the lower edge of our slot. It's the geometry, and we can click OK here. So we define it as a first step as a geometry. Now we will go to define our here you see here this slot is created. That's how we can click here the show to see our the limit value as a geometry of the slot. Cancel, and we go to the create the tool for this operation. So click here the tool, and select this one. Let's select here to create a tool, and for the slot we will use the end mill. So here we have the end mill. Double click on the end mill, and we can use here for example the 6 millimeter of the tool, or we can change here the value. So let's use here the 4 millimeter diameter end mill, and other values will be automatically adjust its values according to this value. You can define these values by yourself, and here you can click here the cutting conditions in order to define the cutting condition for the tool. That is the cutting speed, the feed rate, the rotational speed of the spindle values, and so on. So you can also define the spindle of rotation in the clockwise or the counterclockwise, this option or this option. So I will use the clockwise. So click here the select. So we define the tool for this operation, and you can see here the parameters of the tool here. And let's define here the levels. So in this case, so we'll go to the level, and we need to indicate here the upper level. So here this one option is selected, and click here the upper level. So specify the upper level of the slot. So in this case, just select here the upper face of the upper face. So this is our upper face of our slot, and click OK. And we go to the technology. So in the technology, so we need to check here the first tool side. So now it's the center, but we need to check it. So in order to check it, here the select is a geometry. So this step is important. And if you go to the geometry, and you will see here the tool side is exactly in the center of the edge, but here you see the tool when it rotates in the center, it also removes this portion. So we don't want this one. In order to change here the position of the tool, here you can go to the left, but left is fully on the that side. So in this case, I will use here the right side. So the tool must be located in the inner side of the slot, which is the tangent to this edge. So right side in this case, okay. In my case, so I will accept this tool side. Click OK. And here you can define the step down. That is the step down. That is the every time that removes the material along this height and along the Z direction. So let's make here the 1 mm. So this is the step down. Is basically the specific value that is the related to the characteristics. So it depends on the tool type. So you can look to the library of the tool and define that this value. Let's say I will use 1 mm. So here you can also increase the profile offset. It means the profile offset that tool exactly if the zero, the tool exactly will be the tangent to this position. If you increase this value, the tool tangency will be shifted toward to the center. Now, if the zero, so it will be exactly tangent to this profile while the moving. And if the some material will be remain in the middle of the slot, you can increase these values just to make here to remove this material. So we will see this one if the material is removed remained. So you can make here the one way or the zigzag of the toolpath. So let's use here the zigzag, and now let's create our the toolpath. Save by clicking here the save and calculate. Press the save and calculate. So and you see here our the toolpath is created here. Then you can check here the simulation. Click here the simulate, and we can go to the solid verify and just play here. So click here the play. So this is our the slot. So this the you see moving on the profile. The every time that removes the 1 mm material on the depths. So we can speed up animation speed. Uh, so you see unfortunately the material is remained on the center. So it is we need to make some optimization for this operation. So in order to do this, I will go here in the technology, and as I said here that they increase here the profile offset. So let's use here the 10% of the profile, that's 10. So in this case, I will generate two plus again. So save and calculate. So let's okay here, and let's here this one. So we need to here go to the geometry, and let's use here the another. We need to create a new geometry for this one. So let's here create the new geometry. Let's try to this one, and let's call this the slot one. And again, let's select this edge. So click OK, and click OK here just, and go to the tool. That's the tool is okay. Let's define the levels. So the upper level, that this face is okay. Then go to the technology. Let's check here the auto tool side. Go to the geometry. So right side is okay. Then the 10% of the offset, so it's okay. Let's do this one, and let's generate a toolpath. So we need to let's go to the geometry. So I will let's this one, and let's delete all these geometries. So let me just select here this one. So the slot one, and go to technology. Let's make it here the again 0. Let's generate this one. So toolpath is generated here, but let's again the simulate to see the results. So material is remained. So we need to here let's click here the offset of the 4. So generate here so let me just delete this operation and create another operation. That's the slot again once more with the, so here we need to use the slot. So as a geometry, click here the new and select here the lower edge of the slot. Click yes and accept this one, and we need to check here so go to the tool. Let's select here the tool. So we will use this tool. I will accept this one. That levels that go to the upper level. Let's click here this face. You accept this technology. Let's check the technology. Click here the geometry, and you see tool side is here. That we will change here the left side or the right side. In this case, it's okay. So it will be the inside of the slot. So now it's okay. In the right side, locate here, and let's make sure that this is the 10% too, and step down again 1, and let's generate here. I don't know why it's making this mistake here, because I cannot delete these slots. So let me just close this one. So I will open this file once more time. So let's save it here. So where do I save it here? This one, this one. We find our this one. So let me find this one. This one. So well, okay, here so let me just close the first one. So I will generate here again. Click the milling from the beginning. Just sorry for this one, and click here the external SolidCAM operation. That the unit is metric. Click OK. So you will define the coordinate system. Click here the coordinate system, and I want to locate it exactly in the center. So click here top center model box and click here this surface. So it will be located over the 0 point here. I will click here the OK. So now I will click here the OK again. Okay, in this and the stock to define the stock. So we use the option of the stock here, the extruded option, the boundary, and click here the lower edge of the boundary. So it will create our stock here. Click OK. Okay here. So we defined our initial the values here, and just click OK. So that's defined here the operation. That's the slot again. So go to the slot. Now let's check 0. Okay, there is no any geometry. Now we'll create a new geometry. So new, and select here again the lower face, that's lower edge of the slot. Click OK. The tool, and click here the select. That's the end mill that we will use, and let's make here the 4 millimeter. Let's click OK here and the levels. So at upper level, click here the upper level and select this face, this upper level of the slot. Click OK, and technology again. We need to use here. Just check here the geometry, the pull side. So in this case, let's make here the left side or the right side. So exactly should be in the inside of the slot. Click OK, and let's make here the offset of that 10 and step down that 1. And let's generate here. So let's here the make here the 0 and generate here. So our tool, and let's use here the tool with the let's change here the tool. It's the 6. Then the generate here. So now it's okay that you can click here the simulate, then solid verify. So this play, so we can. So it is okay with the tool with the 6 mm. In this case, it's okay that we can use here this tool. So we created our the slot. So here that is the slot operation is only the use for the slotting. Now we will see here the how to create the pocket. So the pocket in our the model here we have the several pocket types. So here we have the rectangular pocket, we have the circular pocket, and we have the here the open pocket. So we will see the how to create the pocket with the different shapes like the rectangle, the closed, circular, and open. So here we will go with the create the pocket, and we will again define the geometry the first for the pocket. And in order to define geometry, click here the new. So we need to define here the again the edge here of the pocket. So it should be the closest here, and I will accept and click OK here. So the tool again, go to the tool and select here the tool which we created before. This is the tool which we use for the pocket, also the 6 mm that end mill. Click yes here, accept, and the levels. So we need to define here the upper level of the pocket and the pocket depth. So in order to define upper level, click here the upper level and define that this face is upper level of the pocket. Then click OK. And the pocket depth, click here the pocket depth and just show here that this face is the lower face of the our the pocket. Then click OK. Then one need to here the academic here the equal step down, and we can change here the this value. So it is the step down, that's the removing the material on the height on the along the z axis. So as usual, it depends on the tool type. So let's make here to 1 mm. So every time that removes the 1 mm material along the z direction, and we need to go to the technology. And the technology here we define our the toolpaths. That could be the counter, that could be the hedge, it could be the hedge finish. The what is the hedge? If you get here the hedge. The hedge is the yeah, the hedge here. There is the zigzag. So it is not properly to use the hedge for the pocket because some material will be remained on the walls. So it is the better to use for the pocket is the counter option. So the material will not be the removed. I mean the remained. So in the technology, so counter you see it will start from the center and it will go to the towards to the walls and so on. And here you can define the percentage of the overlap, that is the 2% of the diameter along the direction. So now here you can define the materials. So in the offset, so the wall offset, it means that the material remaining in the walls. The floor offset means that material remaining in the floor. So if you make here the 0, 0, and 0 in the all here, that there is no material will be remained in the walls and the floor. So it will be the finishing operation totally, or if you add some the material here, if you want to remain like a roughing operation, let's make here the 1 and 1 here, let's make here the 0, and that means that the 1 millimeter and 1 millimeter material will be remained in the walls and the floors, that's respectively. And you need to add here the finishing operation. Let's you need to activate this one, and this one that's for the finishing operation, so it will be the totally finishing operation. So here we have the technology to define, and we go to the counter option, and in the counter option you can define here the tool that is start from the inside, and it will go, I mean it start from it. If you activate this inside, it will go toward to the inside from the walls, and if you select here the outside, so the tool will go to the outside starting from the inside, and so we can define here the starting position. So it's from the inside, it's from the center, it start in here, it will go start from the outside, go to the center. So you can define here, and also you can define here the corners. If there is no the corners, you see here there will be the flat that and if you make here the fillet, the corners will be the with the some rounds and so on. And here the direction of your tool rotation that we nowadays clean, or it can be the conventional. In the conventional, you see here the tool rotation will be the same as the feed weight. In the clean, it will be the opposite. Tool rotation will be the opposite to the tool rotation. So you can define any of them. So let's here to make the conventional. So it create the more the surface accuracy. Then we will go to the link. So the link, as usual, that's the first interaction of your tool with the material. So that we start from the center. So that's you have several options. If the helical, you see the tool will be in the helical, the engagement that with the material, or you can make here the vertical, it will straightly that engage the first with the material, and you can make here the linear, like here you can make here with the angle. It is better to use here the helical, so it will increase the tool life that helical interaction and so on. So we defined the main settings for the pocket, and we can here click here the save and calculate, and we can see here the tool path which is generated in the pocket. Then we can go to the simulate, and we can solid verify. So then we can click here the play. So this is the tool path. So it will start from the center. You see it will engage with the material in the helical form the first, then it will go with the linear, then on from the center to the outer walls of tower, the to the towards to the walls. Can speed up. So we can close here. So this is we can close this one. So this is the pocket. It's the rectangular closed pocket. Now we will see here how to create the circular pocket. In this case, we need to make here the two depths. Firstly, we will remove until this face, this way, then that final face. So we need to make here the two steps. So let's go to the pocket. So we can use here again the pocket option. So as a first that we need to define here the geometry, then click here the new geometry, and just click here this one. So this one, then click here the yes. So this is the boundary of the pocket, the geometry. Click yes here, okay, and go to the tool, and let's use the same tool. So not to waste time, let's use the same tool for the which is the 6 millimeter. So this one, click here to accept. That's levels. So in this case, select the upper level. Here the upper level is this one. That obviously this will be the upper level of the pocket. Click OK, and go to the pocket depth. and this will be the pocket depth first layer. That until the I want to remove the until the this face. Then click here the yes, and let's make here the step down. That's the 1 millimeter. And as well as technology, you can define the technology what we have done before. So the counter, then you can here to keep the 0 and 0 all these values. That's the offset values in the walls and the floor. And the counter you can start from the inside. Then you can make here the fillet. I mean the fillet. You can click here the conventional and that link. Let's make here the helical. That is the more the better door engagement, and click here to save and calculate. So you see the toolpath is generated. I will on this one, and we can simulate, and that's the make here the solid verify. So it's our two operation. Then click here to play. So this is our pocket. That is the now we will create the second pocket, the circular pocket, which is the on the this one. Let me I just hide this toolpath, so we can hide other toolpaths. Just deactivating this one again. Here the go to the here the pocket. Then as a geometry, click here the new geometry. Define the border. And in this case, my border is this one. That's the I want to remove the material here, the inside of this circle, and click here OK. And the tool, click here to select, and again I will use the same tool. That's this tool which we created for this operation. That level, again upper level. Click here the upper level. In this case, upper level will be this one. So the upper level of the pocket will be this one. Click OK. And pocket depth will be I will rotate and define as a lower face of the model is this one. So the lower face, the pocket depth, click OK. Then technology again, then you can define the technology here. You can go to the counter, that's this option, and make here the corner as a fillet, because we don't have any corner. That's why we can use here the none, because here the circular anyway. Let's use here the conventional. Then link again, make here the helical again is better, and just click here the save. So this is our operation. In the inner pocket, let's just can click here this one and make here the simulate. Sorry, just the moment that here it was the before of this one. You see here the this one order is changed here in the left side. Here this pocket become the first operation before this one. That's why it was the mistake. That is, it is saying here that this one is not machined, and it is saying that if our tool is interacted with the stock values. That's why you need to just here the change order, and I will keep here the interact here in the last option, and then now I can see here the my operation is in the proper order, and I will again go to the here to this operation, this pocket. Let's generate this one once more. Click yes. Let's make here the simulate, and now I can simulate this one. So just play here. You see here the simulate and the solid verify. You see that this bigger pocket, the circular pocket, is already is the machined. That's why it's not problem now. It easily our tool can contact this one, and I can just click here. So to remove the other portion of our pocket, that is the circular pocket. So we can continue. So I will disable this tool passes. So the last the feature here is also the pocket, but the difference of this one is here we have the open pocket. So that's why we need to create a little bit different geometry for this one. So, and here that we easily created our the pockets. This is the was the closet, and here also the closet, the circular one. But here we have the open the pocket. So we need to create a different the geometry for this kind of the feature. So we will use in this case again the same operation. That's the pocket that to click here the pocket. So again, the geometry. We need to define the geometry. Click here the new geometry. So in this case, I want to use another options to select the geometry. I want to click here the deactivate this one, so tangent propagation and constant Z level, and just select here the, for example, this edge. And I selected this edge, and I can see here this is the going continue of the direction of the border. And if you go here, you can change here this direction. Here you can see here it is the changing. If I click here this one, it change. So into this side, into this side, and this side. So this is the condition which I want to continue from this edge, and here I will add click here this one, add selected element. So I will select press this one, and it will continue on this edge. And as soon I will click here the add selected element here, it will be the closed option here, and it will be the here it will be the open it, and I will click here the yes. So here I defined my border for this pocket. So but here since it is the open on this edge and in this edge, we need to give the information that is this edge of the pocket is the open. In order to do this, that's here in the chain, that right click here the chain, and right click, and here go to the mark open the edge. So click here the mark open the edge. In this case, keeping here the mark is open, the single entity, just click here this edge and this edge. So this edge will be the marked as open. So the system that recognize that this point is the open, and the tool will come from the outer side. So this is the important when you are creating the open the pocket. So you need to indicate which edge is the open edge. So in this case, this is our two open edge here. I selected and click OK, and just click OK. So we defined our the geometry for the open pocket here, and we will go to the tool. Then other the steps is the same what we have done so far. So we need to select here the tool, click here the select the tool, and click here the same tool. Let's use the same tool. It's a 6 mm of diameter, that level. Firstly, let's define the upper level. So upper level is this one. So upper face of the pocket. Okay, and the depth, pocket depth here. Click here the pocket depth, and select this face as a pocket depth. I will click OK. So again, you can define here the step down. Let's make here the one, and let's go to technology. And the technology, though, let's make here here the corners. So it is you can you cannot you don't need to change here the corner, since the corner there is no in the corner, since it is the radial corner. And here let's make here the directly finishing operation. There is no material will be remained. That link, let's make here the helical. Let's keep here the helical. You can define here the helic radius and angle. So, and also you can here I forgot this. You can define here the lead in and lead out. So lead in and lead out is the approaching of your the tool towards to the workpiece. So if you make here the normal, it will be the normal approach. If with some angle here, you can see with some angle, and here you can define the angle of the arc, and it can be the tangent approaching like here with a straight line. And also you can define the lead out. So the lead out is the releasing of the tool from the workpiece after making the machining operation, and so you can make here the some arc. Let's make here is the arc and arc, since we have here the arc option, and we can click here the save and generate. So you see the tool path that will be created under here, that here we don't create it because we don't selected that person, and we can click here the simulate. Let's click here the solid verify, and you can click here the play. So it will that remove the material on this corner. That's the open pocket. So we created this operation. The same, we can create. I can select with the tool path here the pocket. The same, we can create the pocket here. Click here the pocket. That's geometry. Click here the new geometry, and again I can use this option. Just select this edge, and here you can see the continue. Then we will add here the selection, this one, and I will continue from if this direction will be the different. You can change here the direction like here. So I will keep to this direction. I will add here this one, so it will be closed again. Click here the yes. So then I need to mark my open edge. As usual, let's click here the chain, that right click, the mark open edge, select the mark open edge, and select here this edge and this edge select. So these two edges is selected as open edge, and click OK. Just click OK here, and let's go to the tool, and let's create a tool. Let's use the tool. This one. You can create another tool, for example, here for this one. I will use the same tool. It's the 6 mm level and the upper level. So that this level, I will select this level as usual as upper level, and here the pocket depth is this level. Then you can define here the step down, just 1 mm, the technology. Then the link that I will keep here all the others the same. We can change here the values. So I will click here the save and calculate the toolpath, and the toolpath is created. Then we can go to the simulate. Click here the solid verify. The solid verify is used in order to see the material removal operation, and we can click here the play. So this is the last operation. So here we created all the operations, and you can here activate all your toolpaths to see all your operation. That is the slot milling, the pocket milling, that circular pocket milling, and open pocket milling. In order to simulate all the operation, then simultaneously in the sequences, you need to just select all the operation. Like here, pressing the control keyboard, you see all is selected, and from here you can go to the simulate, or you can just right click and click here the simulate, and as usual go to the solid verify and click here the play. So here the old operations that will be the simulated in the sequences step by step. So we have finished it. And as usual, to create the G code, I will create this one, and just selecting all of the operation, just right click, and here we have the G code, and we have the generate the G code. You can just click here, shift the G plus G, and just click here to click the G code that you can name. That's why you click here. Okay. Then we need to wait some seconds for the creating the G code for these old operations. Then new file will be opened. Here the G code is created. Then you can see here all the steps starting from the slot milling and the bucket milling. Let me go a little bit down to see here some more information. So it should be written some information about the operation, but unfortunately no information here. So this is all steps in the G code here. So you can save this file here any format. That's the here you can save the several formats. Then or you can save here just the selecting and clicking the copy and so on, just to loading your the CNC machine. So I will close this one. So this was the steps for these operations.